Hello and welcome to Awesome Day 2022. My name is Jack Romanos and I'll be your technical trainer for this session. Introduction to AWS services, compute, storage, and databases. I'm looking forward to walking you through to the foundations of compute, storage, and database services which make up the core of any migration. They're also great services if you're looking to deploy new workloads in the cloud. So let's continue with learning more about AWS. In this first section, we're going to talk about compute. And really, to talk about compute, the first thing we need to address is Amazon Elastic Compute Cloud, or EC2. EC2 is a service we can use to deploy virtual servers. This allows you to deploy or migrate workloads directly from your on-premises infrastructure into the cloud. EC2 supports Linux and Windows, and Mac OS in select regions. It is extremely flexible. It gives you complete control over your servers. However, in order for us to understand what virtual servers like EC2 is, it's helpful for us to get a basic idea of what a server is. When you think about your on-premises infrastructure, you have purchased physical equipment, or servers. At their most basic, servers are made up of CPU for processing, memory for temporary data storage, disk for long-term storage, and networking to allow remote access. What you're seeing here is a physical host, the physical device that underpins a compute environment. When you deploy a physical server in your environment, you have access to all the resources, which is great. However, often you only use 10, 20, maybe even 30% of those resources, which means a large portion of it is going to waste, sitting idle. Resources you've paid for but not actually utilizing. EC2 is a virtual server, which means when you deploy an instance of EC2, you can deploy only the size that you need and change it when you need it. As you can see here, you can deploy an EC2 instance which consumes only the resources you need. You can choose the amount of CPU and memory, and then create a separate disk volume using the Elastic Block Storage, or EBS. We'll talk more on this later. A key feature of EC2 is something known as the Amazon Machine Image, or AMI. This allows us to select the operating system of choice and even have custom applications pre-installed to speed up deployment time. Once the EC2 instance is deployed, you can then run your applications or workloads on them, in a similar way to your existing environment. However, using EC2, we have the ability to add, remove, pause, change, resume, scale, or manipulate your instances as you will. There are different sizes and types of EC2 to help you run your workload as efficiently as possible. So to summarize, EC2 provides you the flexibility to run your workloads when you want to and how you want to. Think of EC2 as disposable, allows you to take advantage of the pay-as-you-go pricing, significantly reducing the overall cost. Now that we know what EC2 is, what are some of the distinct benefits? Let's start with elasticity, the ability to scale your application as demand changes. As an example, let's say you're running a web server. Under normal load, you expect there to be 100 users connected to your application around 12 p.m. As the day goes on, that number really starts to dwindle off. And now you're down to a baseline of, let's say, around 10 users in a given hour or given minute. But what happens if we go above the 100% we're expecting? We have the ability to increase the number of instances that serve the web traffic. We can go up to 200 or 300 or 3,000 concurrent users if need be, by increasing the number of resources under the hood. With EC2, there's various different features built in that give us the ability to scale up or down, in or out, so we can take advantage of that pay-as-you-go pricing that we talked about. The second one here is control. We have the ability to stop and start instances or pause and resume instances for certain supported instances as we need them. Again, that has a price benefit for us, the ability to save costs. When we don't need our instances to be running, we can scale down. But then it also gives us the ability to size our fleet appropriately to the amount of traffic. EC2 gives you flexibility to choose what you want when you need it. There are a number of different EC2 instance types and families we'll talk about in a moment, but you can pick the right type of instance for the right type of job. EC2 is integrated with other services, which enables you to create secure, scalable, and highly customizable environments. There are a number of other benefits to EC2, including reliability, security, which we'll talk a bit more about later. It's cost-effective because you can pick the right type of instance for the job, whether it's a small or large instance with different resources matched to the specific workload you have for EC2. There are a large number of EC2 instance types, which is great as it allows us to deploy the EC2 instance that will be most efficient and effective for your workload. The instance types are grouped into instance families, which can make it easier to understand what each type is best used for, allowing you to make an informed decision. Want to reduce the overall cost of your workload? Choose a general purpose instance. Need more compute grunt to help process application requests or batch processes quickly? Choose a compute optimized instance. Need more memory to help speed up your database? Choose a memory optimized instance. What if you're interested in machine learning or 3D modeling? Choose an accelerated computing instance. Each instance type also comes in different sizes, allowing you to be as cost efficient as possible, while still getting your work done within your committed SLA. We previously learned that the flexibility was a great benefit of EC2, and pricing flexibility is no different. With multiple pricing options to fit your workload and environment, we give you the options to make the decision and configuration that is right for you. On-demand instances can be considered the list price. With on-demand, you have the greatest flexibility and control over when and how you configure and deploy your instances. This is great for immediate scalability, workload changes, temporary workloads, or workloads that cannot be interrupted, but only run for a short time. Reserved instances, on the other hand, give you a significant price reduction for workloads that run permanently. For example, you choose a 1 or 3 year commitment, and the more you pay for the commitment up front, the greater the discount. This is great for steady-state workloads, like your public-facing website, for example. Savings plans are a similar concept. You can commit to a certain amount of capacity that you're going to utilize over time. Lastly, and probably the most interesting here, is spot instances, which give you up to a 90% off the on-demand price, with one caveat. Spot instances are not guaranteed to run permanently. This means that you need to be strategic about how you deploy them. However, they're great for the ultimate cost reduction. As an example, most stateless applications can use spot instances and benefit from the lower cost. We're now looking at the AWS Management Console. Using the console, I'm going to demonstrate how to deploy a simple public transport application built by launching an instance using the EC2 service. We'll first navigate to the EC2 service dashboard, and then we'll select the Launch Instance button. From here, we'll step through a wizard to go about configuring the launch details of my new instance. I'll give this a name, which will just be Jack's Transport App, and then I'll select the Amazon machine image, which will include my choice of operating system, the latest version of Amazon Linux 2. I'll then change my architecture to use ARM. From here, I'll select my instance type. This is a simple web application. I'll choose an instance type that's most appropriate for a typical web server with 2 virtual CPUs and 2 GB of memory. I'll then opt out of selecting a key pair as I don't need to connect to this instance remotely. I can configure my network settings, but for this demonstration, it's fine to leave most on default. I'll have make some network security changes to allow public HTTP web traffic to the instance from anywhere on the internet, so that later we can access my transport application. I'll leave my storage settings on default, where it has an 8 GB root volume attached to the instance. Lastly, I'll add a script which will install my application and its dependencies upon launching my instance. I'm now all set to launch my EC2 instance and check out my transport application. My new instance will have a unique ID and a link to view it. This will take me to a dashboard showing my instance details. When I select my instance, you'll see here that it's now in a running state. In the Details tab, I can see information about the instance, such as its public and private IP address. In the Security tab, I can see security details, such as its inbound and outbound rules. Under Networking, I can see its virtual private cloud and subnet. Under Storage, I can see its attached EBS volumes. I also have tabs available for status checks, monitoring the instance metrics, and managing resource tags to find instance or group it among other resources. At this point, my application should have been deployed on my instance. So I'll copy its public IP address and paste it in my browser. Now we're able to view my transport application running smoothly on my instance, and I can log in and test my user account. Now that I'm logged in and I can see my routes, I now have a functional transport application that I can use when planning my trips around New South Wales thanks to the EC2 service. After I've finished with my application, I can terminate my instance as I no longer need it. I'll select my instance state and then I'll click Terminate. My instance is going to be shut down and then removed from my AWS account, so I no longer have to incur any costs. Another concept that I want to introduce here is unmanaged versus managed services. With unmanaged, you need to manage the scaling, the fault tolerance, and availability on your own with your application or architecture. Keep in mind that if you were running this application on premises, you'd be managing this anyway, including managing the physical infrastructure. But one of the key advantages to some of the services that we're going to be talking about here is that there's actually a managed, or in some cases, fully managed option where you don't have to worry about the scaling, the fault tolerance, and the availability, which are built into that service. And so the reason I introduced that is we're going to now shift gears a little bit and talk about serverless computing, which is something you may have heard of. EC2 is great. It's extremely powerful, configurable, flexible, and gives you control over your application and how it runs. But that power comes with responsibility. You must manage fault tolerance, high availability, scalability, the operating system, and application patches, access, permissions. It's a full server. But maybe you don't want to worry about the administrative side of compute. You just want to run some code. Maybe you have an application where some parts get run frequently and others not so much. Maybe you have an ad hoc calculation that needs to be run, or reactionary code that responds to events in your environment. Having a full server sitting there, idling, waiting to be interacted with, it's quite a waste of resources. So how can we do this better? With serverless computing, we have the ability to build and run applications and services without managing the servers that we just talked about. So we can still get the outcome of running specific code or function without having to manage all the underlying components. A key benefit here is no service to provision or manage, which leads us to never paying for idle resources. And so this is where serverless can greatly help us. If we can run our applications in a serverless manner, we can actually save by never paying for idling resources. So now that we've talked about what serverless computing is, let's talk about the heart of serverless, AWS Lambda. Lambda is a fully managed compute service, which runs stateless code, supports multiple different programming languages, and you can run your code based on a trigger or schedule that you choose. This gives us some great benefits. Previously, we talked about EC2 instances, which require us to provision or choose the right type of instance to run our application. With Lambda, we just need to add our code to something called a Lambda function, then tell it when to run. Lambda manages the execution and completion of the code. You don't have to worry about deploying infrastructure or anything. AWS Lambda excels at executing short-running, stateless code that has a defined start and finish. For code that runs indefinitely, you want to stick with something like EC2. But a little cloud design allows you to take advantage of what Lambda has to offer. Lambda also helps us add automation into our environment. Whether it's an automatic logging, response and remediation, incident management, analysis, the list is endless. Let's look at an example using Lambda. We're going to have a basic scenario where a user could upload a picture to a storage location, in this case an S3 bucket. We'll learn more about that in the storage section coming up. We want to do some image recognition when the image lands in the bucket, so we invoke a Lambda function to use an image recognition service when this occurs. So in this example, a user uploads a picture to S3. S3 triggers Lambda, and Lambda uses another service to perform image recognition, then it stores the results in a text file back in the S3 bucket. We'll call this an event-driven architecture, where there are no active servers running. Let's look at how this is built. I'm going to walk you through an environment that is pre-built to show you how it all ties together. We're now looking at the Lambda dashboard in the AWS Management Console. From here we can create our Lambda function. We're going to author one from scratch and give this a name of AWSome Image Recognition. We'll then select our favorite runtime. I'm happy with Python 3.9 and the ARM architecture. I'll then change my default execution role. This will give my Lambda function permission to access the images in my S3 bucket and to perform image recognition on them. So I'll choose an existing set of permissions that I've already pre-configured. I'm now ready to create my Lambda function. Now that my function is created, you'll see that I can edit my function code. It has some example code for me to begin with. However, let's replace this by pasting in my own Python code. This code allows us to receive an image from an S3 trigger, perform image recognition, then store the results of it back in the original bucket as a text file. Once we've added our code, we can now save and deploy our function. I'll now navigate over to my S3 bucket. I'm going to edit its properties and add a trigger to invoke my Lambda function when I upload an image. So I'll scroll over to Event Notifications, click Create Notification, and give it a name. I'll specify a .jpeg only suffix so it only runs for JPEG files. I'll also make this only trigger on new upload events. And finally, I'll select my Lambda function, which we just created as the destination of this event. Now we'll click Save and test it out. I'm back at my bucket and I want to upload a photo I took, which is a delicious pan pizza I cooked the other day. It's called lunch.jpg. I'll now drag and drop lunch.jpg into my bucket and upload it. Now that it's there, you'll see it listed inside my bucket. In the meantime, this will trigger my event notification to invoke my Lambda function and perform image recognition. When I click refresh, you'll see that the Lambda function has dropped our results as a text file into the bucket too. Let's download it and see inside. And finally, I can see that it has confirmed with 99% confidence that my pizza is in fact a delicious pizza. There are many other serverless services within AWS that we can integrate together. We saw the event notification from S3 as an example, but let's see other applications and use cases for serverless. So in the example that we just saw with Lambda, we did something very simple. But what if we want to create an entire backend? We can also do that in a serverless fashion as well. We have many different Lambda functions and other services within AWS that will integrate with Lambda so that we can create an entirely serverless backend. Maybe you're performing data processing or creating reports. Maybe even having chatbots or other IT automation tasks. All serverless in the backend, and we don't have any running or worst case idling resources. This is one of the key advantages of going the serverless route. In some cases, you might not want to run a full EC2 instance 24/7 waiting for actions to occur. But what if you have a job or something that is going to take a short period of time, but needs to run longer than it could within Lambda? Containers can really help us here. Amazon's Elastic Container Service, or ECS, is perfect for orchestrating the execution of your containers. This can be done on EC2 or even have ECS manage the infrastructure deployment for you. It maintains and scales the fleet of nodes that run your containers and removes the complexity of standing up the infrastructure. Containers give us a balance between the long-running compute that EC2 gives us, whilst also being extremely quick to scale and run, which is where Lambda excels. Let's have a quick look at how Elastic Container Service helps us manage container orchestration. So, ECS actually gives us the ability to schedule and orchestrate the deployment of our containers, as they're called across multiple or even a fleet of EC2 instances. Typically, this is a complex activity because it requires determining where you might place those containers using a placement engine. And so, the ECS service gives us the ability to manage containers at a scale on EC2. We've spoken a lot about compute, EC2, Lambda, and ECS. Let's move on to storage on AWS. We have a number of different storage options, depending on your application's needs. S3, or Simple Storage Service, is a scalable, highly durable object storage in the cloud. We've also got S3 Glacier for low-cost, highly durable archive storage in the cloud. We've previously mentioned EFS, a scalable network file storage service for multiple EC2 instances. We talked about hybrid cloud deployment in previous module. With Storage Gateway, we've got a hybrid cloud storage service that gives your on-premises environment access to virtually unlimited cloud storage. And lastly, we have EBS, which we saw when deploying an EC2 instance. EBS is network-attached volumes that provide durable block storage for EC2 instances. Let's start with S3. S3 is object-level storage, which means S3 manages the storage layer for you. S3 is designed for what we call 11 nines of durability. Durability is a measure of how likely you are to lose a file or object. For example, if you store 10 million objects with Amazon S3, you can on average expect to incur a loss of a single object once every 10,000 years. That's extremely durable. But there is no limit to how much data you can store in S3. So you can store as many objects as you like. However, each object cannot be larger than 5 terabytes in size. We previously saw event triggers in the Lambda demo. This is a great feature of S3 that enables fantastic automation and event-driven architectures. S3 objects are stored within buckets, which are basically like containers that you create. You can also enable replications of objects between different buckets to create additional copies that data within the same region, or maybe even a different region if you need to. And then similar to our pricing discussion before with EC2, you can also utilize different pricing models for your storage data, depending on different access patterns that you might have for your application. These are called S3 storage classes and range from immediate accessibility for hot data all the way to archival options with long access times for cold or frozen data. Some example use cases for S3: content storage and distribution, backup and archival storage for big data and data analytics, disaster recovery, and static website hosting. There are a few main things to understand about the S3 service. It's built to store and retrieve data. It offers fast, curable, highly available access to your objects. As I mentioned earlier, you can store an unlimited number of objects in a bucket. A key benefit to S3 is that you can access objects from anywhere on the web, whether it is serving externally to a user or internally within your environment. So let's actually look at an example here of what a round trip looks like. So you might have a client, let's say either an end user through a web browser, or a web interface, or potentially an application that is looking to get or retrieve data from S3. The client will need to send through a HTTPS request to get an object from the bucket. The S3 service then sends the object back to the client. It's that easy to retrieve and store data in S3. In the introduction to the cloud, we spoke about AWS Global Infrastructure. One of the infrastructure elements is a region, which is a geographical location. It's important to think about which region to place your resources and store data in. Generally, it comes down to 3 or 4 priorities. The first priority is data residency or compliance. If you have a regulatory or legal requirement that dictates where your data is kept, maybe it has to stay within the same country it originated from, then you must choose the appropriate region. However, if this is not the case, then you have some flexibility to choose. Secondly, we want to locate the service as close to the customers who are going to use it. This will help improve performance and give them a better experience. Third, it comes down to service and feature availability. Not all services are available globally, so sometimes you might choose a region that actually contains the service you want to use. And then last, but by no means least, is cost. Different regions have different prices. Sometimes choosing a different region can help you reduce costs of your workload. So let's move on to Amazon S3 Glacier. S3 Glacier is designed for long time, infrequently accessed archival storage. The key difference between S3 and S3 Glacier is access time and cost. With S3, objects are accessed immediately. Want to load up an image for your website? It's right there. With S3 Glacier, however, there is an access delay. This can be between minutes to hours, depending on how you configure your environment. However, with that access delay comes a drastic reduction in storage cost, sometimes as low as 90% cheaper than S3 standard storage. With S3 Glacier, the focus is on long-time archival storage. Some example use cases are healthcare or financial information that you need to keep permanently, but only access rarely. Maybe you have a video asset where you keep the raw or mezzanine quality videos in low-cost storage, which allows you to reuse later if need be. When thinking about using S3 Glacier, just ask yourself, how much data am I storing? How long do I need to store it? For how often do I need to access it? And what cost is acceptable for storage? The last service we'll talk about in this section is Elastic Block Store, or EBS. We saw how this service is used with EC2 earlier. It provides persistent block storage for our EC2 instances. EBS volumes come in a variety of different types with different underlying physical components. This allows you to apply an appropriate volume to the type of workload. For example, if you are running a database that is reliant on low latency, random access, a provisioned IOPS SSD may be perfect. However, if you're more interested in streaming large logs files, then throughput-optimized hard disk drive may be better suited. The volume types also let you reduce your cost for storage. EBS volumes also support snapshots, which are backups of your volumes. These snapshots are stored in S3 behind the scenes, so you get great availability and durability of your backups. Lastly, EBS supports at-rest encryption to keep your data secure. Next up, let's talk about databases. AWS has the broadest selection of purpose-built databases for all your application needs and allows you to scale your largest and most complex workloads so you can grow to reach more customers. Listed here are some examples of databases that could fill your needs. Earlier, I introduced the concept of unmanaged versus managed services. Well, here I want to talk about do-it-yourself databases versus AWS managed databases. You can definitely run your database choice on EC2. There are a few valid use cases for doing this. Maybe you need to access the underlying operating system to install helper services. Or maybe you need to use a database engine for legacy compatibility that AWS doesn't support. However, if you go down this path, you must manage the high availability and fault tolerance, the database backups, primary, secondary replication, operating system, and database engine patches. The administration tasks are quite extensive. Running a database on EC2 is an example of using an unmanaged service. You could instead, though, choose to deploy your database on one of the AWS managed database services. Some examples are Amazon Relational Database Service, or RDS, for SQL-based databases. There's also Amazon DynamoDB for NoSQL databases, Amazon Elasticache for in-memory caching, or Amazon Redshift for data warehousing. When choosing a database, previously it was always we have an SQL-compatible database, this is what we use, so this is what we'll continue to use, even if the use case didn't really fit. Now with the cloud, you have a plethora of database options to choose from. Our first choice must be to SQL or NoSQL. SQL databases are great when needing to join tables, needing to perform complex analysis, or have a flexible yet complex querying. Maybe you know what your data looks like, but you don't know how you want to query it. NoSQL databases, on the other hand, can be extremely fast and provide low latency responses. They support ad hoc data structures and can scale differently to a traditional SQL-based database. So, how do you choose? For a relational style database that has transactional requirements, look no further than Amazon Relational Database Service, or RDS. If you need a relational style database but require analytical processing, then Amazon Redshift is your service. For storing your data in a non-relational way for transactional databases, Amazon DynamoDB may be a good fit for those needs. But you might also need a graph database, which is more focused on the relationship between data points rather than the data points themselves. You might use this for fraud detection or recommendation systems. Amazon Neptune has you covered there. Lastly, Amazon Elasticache provides a caching solution and is available with two popular caching engines, Redis and Memcached. This is only a sample of databases on AWS, but regardless of your application's needs, there's a purpose-built option that you can migrate to or stand up in the cloud. So first up here, we have Amazon RDS. RDS makes it easy to set up, operate, and scale a relational database in the cloud. It provides cost-efficient and resizable capacity while managing time-consuming database administrating tasks. And that frees you up to focus on your applications and your business. RDS supports 6 familiar database engines that you can choose from, including Amazon Aurora, which we'll talk about, Oracle, Microsoft SQL Server, Postgres, MySQL, and MariaDB. Amazon RDS also provides a number of features that make it easier to manage common database tasks. Once you've created your RDS database, you can configure automatic backups and maintenance windows while working around your application traffic. By default, Amazon RDS enables automated backups of your database instance with a 7-day retention period. RDS also gives you the ability to run your database instance in a multi-AZ deployment, which increases fault tolerance by maintaining a synchronous replica for automatic failover. Lastly, you can scale the compute resources and storage capacity needed for your database over time as your data or your demand for your database grows. We've also got Amazon Aurora, which is a MySQL and Postgres compatible relational database built for the cloud. It combines the performance and availability of high-end commercial databases with the simplicity and cost-effectiveness of open source databases. Aurora is built for high availability and durability. It's also built for high performance and scalability, whilst providing multi-regional capabilities. There are some neat features of Amazon Aurora that sets it apart from other relational databases. Aurora has a distributed, fault-tolerant, and self-healing storage system. The data blocks are continuously scanned for issues and repaired automatically. You can utilize up to 15 read replicas on Amazon Aurora across multiple availability zones, which share the same underlying storage volume as the primary database instance. This enables really great read scaling and high availability for your applications. Another great feature is Amazon Aurora Serverless, which provides on-demand access to your data with automatic startup, shutdown, and scaling. This is another great option to save costs on those unpredictable or spiky workloads. The last thing to mention is that Aurora is up to 5 times faster than standard MySQL databases and at a tenth of the cost. Next up, we have Amazon DynamoDB, which is a fast and flexible, non-relational database service for applications that need consistent, single-digit millisecond latency at any scale. The fully managed nature of DynamoDB makes it really flexible for many different use cases, but also takes away a lot of the management tasks. DynamoDB handles all the partitioning of data in your table, so you don't have to worry about managing those different partitions yourself. You also get fine-grained access control with identity and access management. And since there's no underlying instance to manage, you can configure the read and write capacity for your DynamoDB tables, ensuring that your application has the right throughput. Where you might have spiky workloads, DynamoDB features on-demand and adaptive capacity options. In most cases, DynamoDB offers single-digit millisecond response times, but sometimes your application needs even faster response times. In these cases, we have something called DynamoDB Accelerator, or DAX for short, which is an in-memory API-compatible cache that reduces response times down to microseconds. Lastly, DynamoDB provides the ability to create a multi-region, multi-active configuration with something called DynamoDB Global Tables. And that frees you from having to roll your own replication solution. Talking quickly about a DynamoDB use case. Companies in the gaming industry use DynamoDB and all capabilities of game platforms including game state, player data, session history, and leaderboards. As there is little operational overhead, game developers can focus on developing their games instead of actually managing databases. I hope you've enjoyed this session and found it interesting. AWS is a data-driven company, and I'd like to take this opportunity to ask you to complete a survey telling us what you thought of this session. This can help us shape and improve events and learning in the future. You can also reach out to us on the various social sites listed on the slide. Why not test your knowledge? Make sure you complete the knowledge check after the session to see how you're progressing. Thanks for attending Module 2, and stick around for Module 3.
Hi everyone, and welcome to AWSome Day online conference. My name is Akanksha Balani. I'm the Alliance Lead for AWS at Intel for the region of APJ, and I'm also the Global HPC and AI GTM Lead. With us in the industry today, time and time again, we've recognized is when there is a technology that's accessible, that's consumable, and when the barriers of its adoption are low, this gives rise to a crazy amount of demand. And through that demand rise various business models, various usage models, and ultimately, a lot of opportunity. Cloud computing is one such technology, and AWS has continued to bend the curve of what's possible. The rest of my session today will talk about how, with the power of AWS, Intel supporting the performance of AWS, you'll be able to unleash the power of cloud computing through various technologies with optimization capabilities brought to you by Intel. So let's get started. Let's talk about the world in which we live in today, filled with data. There is a survey that shows that by the year 2023, we shall have 50 billion devices and 500 million sensors smartly connected over the internet. 46% of these devices will communicate machine to machine. The data is upon us, and it's deluged like never before. to make sure that that data does what it needs to do to help you get the insight for solving your business challenges, your organizational business challenges, or your customers' business challenges. You need to make sure that you're adopting the right technology that can help you scale and build agile solutions for helping you drive the right insight. Cloud computing will get you there. Computational power that boosts performance on cloud computing will get you there. If you look at all the various industries on the slide, each of these industries that you either belong to or you service to or you build for are being impacted by data today. Making sure that you're modernizing your infrastructure, making sure that you're leveraging cloud infrastructure, and making sure that that infrastructure is best performant and optimized for your needs becomes a very, very important and crucial strategy that you need to apply into these industries. Since we've talked about data, since we've talked about industry transformation, let me tell you a little bit about the journey Intel has had. Intel has moved away from being just a PC-centric organization to a strong data-centric organization, so much so that 93% of the world's data runs on Intel. And those numbers are showcases on its own. Whether you see that we have 81 million Xeon processors that are supporting data center cloud to edge infrastructure, or the fact that we have 20 years plus of technology leadership that's helping make compute relevant, performant, and bring down TCO for every solution that you own. It is a data-centric journey that we take on, either on the cloud or on the edge. We want to make sure that with the performance driven on Intel, with computing that's provided on the cloud by AWS, you have the most optimized solution for your needs. I'd like to also take you through the journey of what Intel has been doing with AWS since the past 16 years. Intel has been customizing its silicon year on year, iterating on its technology to be made available on AWS's cloud platforms. If you look at the circle of services and platforms that you probably are already playing around with on AWS, whether it's the EC2 compute, or it's the storage on S3, or the various migrations that you're driving on your databases, whether it's Windows or SAP HANA or SQL Server or Oracle, all of those have the capabilities of being powered by Intel instances on AWS today. We also have very strong and very strategic workloads like AI, like HPC, like IoT, and even hybrid, where Outpost, which is their latest offering on AWS for hybrid cloud, is powered by Intel again. So as you can tell, Intel is about making sure that we have the most customized and most optimized compute capability to help power any of the workloads that you see on the slide today. And if you look to the right, you could actually see the plethora of Intel products that are available for your global workload needs. You could see that we have over 250 plus instances, and I'll go into that in my next slide. This slide actually talks to you about the portfolio of the Intel Xeon instances that are available on AWS's EC2 platforms. And as you can tell, not only is the number of instances quite intense, which is about 250 plus instances that are powered by Intel today, but you could see that it is catering to various needs of your applications, whether it's general purpose, or it's compute optimized, or it's accelerated compute, storage, or memory. Depending on the need of the application and the instance type, we are there with you hand in hand to help provide the lowest TCO at the highest performance. If you look at the range of AWS instances that are powered by Intel technology, we work together to design instances by the compute or memory or storage optimized ones to ensure demanding enterprise applications can run in an optimized and scalable manner in the cloud. The goal is one architecture from edge to the cloud, so that if there is any optimization we make in the cloud, this will also benefit at scale. Let's dig a little deeper into what I just discussed. It's easy to claim industry-leading price performance now, but I'd like to back that up with data. Recently, in an article published by HPC Wire, Amazon EC2 instances powered by Intel measured at having a 1.25x higher performance and price in SpecInt over other x86 technologies. Why does this matter? Intel's architecture can do more with less. This translates into real savings for you, especially when considering the impact of software licensing. A single core of Intel Xeon scalable processors will do what takes 2 or 4 cores, depending on the workloads of another technology. Again, this is about delivering both value and performance. Now that I've explained the performance numbers, let's discuss value. Intel has over 20,000 software engineers that work out of our 1,000 ISV ecosystem partners to optimize, validate, and test applications. So each new version of VMware, Microsoft Windows, Microsoft SQL, Oracle, SAP are all optimized and validated to work on past, present, and future Intel architectures. This allows you to focus on your business and not on revalidating your architecture when transitioning onto AWS Cloud. Again, to back that up with data, the next 2 data points show the workload optimization work that has been done by Intel and AWS to deliver up to 1.7 million transactions per minute on MS SQL. For those of you who work with databases, you know the work involved with SAP HANA. AWS, powered by Intel, is SAP certified and delivering up to 480K SAP's benchmarks. Again, this is where the value of Intel in your AWS cloud instances matter. You can focus on running your business, knowing that Intel and AWS have delivered industry-leading certified performance to meet your needs. I'll now go into the actual portfolio of the Intel instances that are available on AWS EC2 today that are optimized by your use case. It's not exhaustive, and it's definitely focused on trying to get you access to the latest and the greatest instances that are available on EC2 today. So for those of you that are building on balanced workloads, which are basically catered towards general purpose, you can use the T3s, the M5s, the M5Ds, as well as the M5ZNs. These are the set of Intel Xeon instance families that help you with general purpose application optimization. When you move forward to more advanced workloads, compute-intensive workloads like HPC, like data lakes, like AI, or network appliances, the compute-optimized versions are C5, C5D, and C5N. Of course, I'm not going to get into the details of the actual hardware features that are powered on each one of those. These are available for your view on the slide. But you could see the performance, the number of vCPUs, the core count, as well as the memory that you can get access across each one of these instances. The third is high-performance databases, in-memory databases. If you are a DB person, you want to make sure that you are trying to drive the best memory and optimized journey of the memory that you require for your application. Use the R5s, the R5Bs, the X1s, the X1Es, the Z1s, or the bare metal instances. They will get you that performance because they're custom built for in-memory database application development. And then let's move on to high IOPS at low cost for storage optimized applications. The i3s, the i3ENs, the H1s, the D3s, and the D3ENs will get you that capability of making sure that you have the highest IOPS at the lowest cost, get you that storage optimized experience for the applications on AWS. And lastly, let's look at accelerated workloads like machine learning or 3D rendering, which is under accelerated compute. Whether it's AI or it's any of the other extended workloads for training or inference, Intel Xeon instances are powering the P3DNs, the G4s, the F1s, and also the latest and the greatest to be coming in shortly across the world are the Habana Gaudi instances that are specifically meant for providing you a 40% better price and performance over existing deep learning GPU-based training instances on AWS today. So if you're looking for the broadest choice of optimized instances that are tuned for your enterprise workloads, try out the various Intel instances that I went over on AWS's EC2 platforms. For all of you data-centric workload developers, application managers, when you're working on database migrations, when you're working on data analytics or big data on AWS across the various databases like SAP, SAP HANA, VMware on AWS, Oracle, or SQL Server, you could see the various hardware features that are nurturing the best price as well as performance on Intel-powered instances. In addition to just the data-centric workloads, you also saw me talk about the Habana Gaudi processors on machine learning and AI that will provide you the a 40% better price as well as performance on existing GPU training instances on AWS today. Not only will Habana processors help you on your training journey, but the existing C5 instances that are powered by Xeon that have deep learning boost capabilities, vector neural network instruction sets, as well as AVX512 instruction sets built into our hardware, they will also help you basically start your journey on AI on CPU-powered instances, which will give you an immediate price as well as a performance betterment. In addition to AI and ML, we also have HPC as a very strategic workload. We have been working with HPC customers since over 50 plus years. And so the optimizations across HPC workloads and further optimizing AWS's HPC offerings like parallel cluster, EFA, under C5N or C5 or M5 is an experience you will get like never before. Also, in addition to that, if you're embarking on your hybrid cloud journey, you've got Amazon Outposts that are powered by Intel instances today. We also have various COEs that we have also launched in APJ that will help you get that experience of hybrid cloud for you to really experience the optimization capabilities on hybrid on Intel and AWS. Also IoT. For all of you IoT developers and people working in the edge or the IoT world, we also have IoT Core and various AWS's IoT services that are powered by Intel instances. Hence, if you could look through all the various strategic workloads that I mentioned, historically, as well as existing use cases are available for you to see the price as well as performance betterment on Intel-powered instances through the optimizations and the iterations we take on technology along with AWS. Let's also hear from our friends at AWS for them to talk about their experiences on Intel-powered instances across the various workloads.
Amazon and Intel have been collaborating on new technology for over a decade. Together, we've been able to pioneer new EC2 instance families which provide dramatically more bang for buck, more computational power at lower cost, which lets customers do more for less. The new C5 instance family, which we announced in November last year, is powered by a custom Intel Xeon scalable processor with a new microarchitecture, new hardware acceleration capabilities, and support for Intel's AVX512 instruction set. The Intel Xeon scalable processor, combined with the innovations in networking and acceleration in the C5 instance family, bring about a major epoch in the world of high-performance computing, machine learning, and artificial intelligence. It's never been easier and more cost-effective to collect data at any scale, store it in a broad set of database and storage services, and then build custom machine and deep learning models. Today, businesses deploy more machine learning workloads on AWS than any other platform, including Aon, a large insurance and capital advisory company, who is running financial simulations using machine learning on AWS, which reduced the time to complete simulations from days to minutes. And the computational power of the Intel Xeon scalable processor lets customers use more data to create innovative new products and experiences powered by machine learning. Together with Intel, we've optimized deep learning engines with the latest version of the Intel Math kernel library and the Intel Xeon scalable processors available on the new C5 instance family to increase inference performance by over 100x. We've also worked closely with Intel to demonstrate how you can use familiar tools such as Apache Spark and BigDL to easily build distributed deep learning applications on AWS. High-performance computing allows engineers and scientists to solve complex, compute and data-intensive problems. HPC apps often require high network performance, fast storage, large amounts of memory, and very high compute capabilities, making them an ideal workload for our compute-optimized instances, including the new C5. Running these workloads on AWS gives customers instant access to thousands or tens of thousands of EC2 instances running Intel Xeon processors, allowing them to increase the speed of research in a cost-effective way that would not be practical in most on-premises HPC environments. For example, Novartis used 10,600 EC2 instances and approximately 87,000 compute cores to conduct 39 years of computational chemistry in just 9 hours, screening 10 million compounds against a cancer target. This magnitude of improvement is changing what is possible in industries such as healthcare, life sciences, financial services, scientific research, aerospace, automotive, manufacturing, and energy. We're super excited to see our collaboration with Intel continue, and for customers to continue to innovate on AWS through the best performance available anywhere.
And so to summarize, if there's 3 points that you want to take away, number one, you could see that Intel and AWS have a very close collaboration that has resulted in best-in-class end-user experience and customer successes. We would love for you guys to be part of that journey with us. Number two, instance types with the best TCO on Intel to accelerate your customers' applications across the variety of workloads that I went over. And number three, we have existing solutions for deployment with many successful outcomes, delivering both high performance as well as cost savings. So with these three big takeaways, we invite you to embark on the journey of collaborating with Intel and AWS across the various services that you're testing out. And let's make cloud computing as performant as possible with the power of Intel and AWS. I hope you found this session useful. Thank you so much for your attention. Once again, I'm Akanksha Balani, the AWS Alliance Lead for AWS at Intel for the region of APJ, as well as the Global AI and HPC GTM Lead. Feel free to hit me up on LinkedIn or reach out to me through your AWS's contacts, and we look forward to doing wonderful things together. Thank you again.